Here we are with Lesson 9 from Unit 7, Decimal Expansions of Fractions, Part 1. So do the opening exercise and then continue the video to check your answers. Alright, you should be done with the opening exercise. So go ahead and check your answers and make any additions or corrections that you need. Alright, let's go on to example 1. So we're going to write the decimal expansion of the fraction 5/8. Based on our previous work with finite decimals, we already know how to convert 5/8 to a decimal. We will use this example to learn a strategy using equivalent fractions that can be applied to converting any fraction to a decimal. So what is true about these fractions and why? Well, 5/8 is the same as 10/16, which is the same as 50 over 80. The fractions are equivalent. In all cases, when a numerator and denominator of 5/8 are multiplied by the same factor, it produces one of the other fractions. For example, 5 times 2 is 10 over 8 times 2, which is 16. And 5 times 10 is 50 over 8 times 10, which is 80. So what would happen if we chose 10 to the third power as this factor? We will still produce an equivalent fraction, but note how we use a factor of 10 to the third power in writing the decimal expansion of the fraction. So we have 5/8 is equal to 5 times 10 to the third factor over 8 times 1 over 10 to the third power. When we do that, we have 5,000 over 8 times 1 over 10 to the third power. Now we will use the long division algorithm and what we know about division with the remainder for 5,008. So 5,008 times 1 over 10 to the third power is represented division-wise as 625 times 8 plus 0 over 8 times 1 over 10 to the third power. We can separate this by making this an addition problem. So 625 times 8 over 8 plus 0 over 8 times 1 times 10, or 1 over 10 to the third power. That leaves us with 625 plus 0 times 1 over 10 to the third power. And 625 times 1 over 10 to the third power is 625 over 10 to the third power. This is 625 thousandths. Because of our work with the opening exercise, Part A, we knew ahead of time that using 10 to the third power will help us achieve our goal. However, any power of 10 would achieve the same result. Assume we use 10 to the fifth power instead. Do you think our answer would be the same? Well, yes, it should be the same, but we would have to do the work to check it. So let's verify that our result would be the same if we use 10 to the fifth power. So, starting off again and multiplying by 10 to the fifth power, and then also its reciprocal times 1 over 10 to the fifth power, we have 500,000 over 8 times 1 over 10 to the fifth power. This becomes 62,500 times 8 plus 0 over 8 times 1 over 10 to the fifth power. Separating this into addition, this would be 62,500 plus 0 over 8 times 1 over 10 to the fifth power, which is 62,500 times 1 over 10 to the fifth power, which again is 62,500 over 10 to the fifth power, and that is 62,500 hundred thousandths, which again is the same as 625 thousandths. So using 10 to the fifth power resulted in the same answer. Now that we know, we can use any power of 10 with the method of converting a fraction to a decimal. This process of selecting a power of 10 to use is similar to putting zeros after the decimal point when we do long division. You do not quite know how many zeros you will need, and if you put an extra one, that is okay. Using lower powers of 10 can make things more complicated. It is similar to not including enough zeros when doing the long division. For that reason, it is better to use a higher power of 10 because we know the extra zeros will not change the value of the fraction nor its decimal expansion. All right, let's take a look at example 2. Write the decimal expansion of the fraction 17 over 125. We go through the same process to convert 17/125 to a finite decimal. We know from the opening exercise part B that we need to use 10 to the third power to write 17/125 as a finite decimal. But from the last example, we know that any power of 10 will work. So 17/125 is the same as 17 times 10 to the third over 125 times 1 over 10 to the third power. So what do we do next? Well, since 17 times 10 to the third power is 17,000, we need to do division with the remainder for 17,000 over 125. So do the division with the remainder and write the next step. Go ahead and pause the video until you are done. You should have 17,000 over 125 is 136. Therefore, 17/125 is 136 times 125 plus 0 over 125 times 1 over 10 to the third power. Now let's finish the work and write 17/125 as a finite decimal. So 136 is times 1 over 10 to the third power, which is 136 over 10 to the third power, which is 136 thousandths. All right, example 3. Write the decimal expansion of a fraction 35/11ths. Now we apply this strategy to a fraction 35/11ths that is not a finite decimal. How do you know that it's not a finite decimal? Well, you know that the fraction will not be finite decimal because the denominator is not a product of 2's and or 5's. So what do you think the difference will be in our work? Well, when we do the division with the remainder, we will likely get a remainder, unlike the first two examples that had a remainder of 0. So we're going to arbitrarily use 10 to the 6th power to make sure we get enough decimal digits in order to get a good idea of what the infinite decimal is. We can pick any power of 10, but we don't want to make the number too cumbersome, so maybe 10 to the 10th power would be too much. And like we mentioned before, we don't want to pick too few, so 10 to the third or fourth might not be enough. So 10 to the 6th is just an arbitrary number we have picked, and that's kind of a number in the middle part that should give us what we need. So 35 over 11ths is equal to 35 times 10 to the 6th power over 11, which is times 1 over 10 to the 6th power. So what do we do next? Well, since 35 times 10 to the 6th power is 35 million, we need to do division with remainder for 35 million divided by 11. So we need to determine what numbers make the following statement true. 35 million is equal to some number times 11 plus some number. Well, that would be 3,181,818, and 2 would give us 35 million. So it would be 35 million is equal to 3,181,818 times 11 plus 2. So with this information, we can continue the process. So 35/11ths is the same as 3,181,818 times 11 plus 2 over 11, and multiplied that by 1 over 10 to the 6th power. So using this as an addition problem, we get 3,181,818 times 11 over 11 plus 2/11, and then multiplied by 1 over 10 to the 6th power. Well, now that since we have that cancels out, and we have 3,181,818 plus 2/11 times 1 over 10 to the 6th power. Using distributive property, we're going to multiply both terms by 1 over 10 to the 6th power. So we have 3,181,818 times 1 over 10 to the 6th power. And then we're adding 2/11 times 1 over 10 to the 6th power. This gives us 3,181,818 divided by 10 to the 6th power plus 2/11 times 1 over 10 to the 6th power. So writing this as a decimal, we get 3.181818 plus the quantity or the product of 2/11 times 1 over 10 to the 6th power. So at this point we have a fairly good estimation of the decimal expansion of 35/11 as 3.181818. But we need to consider the value of 2/11 times 1 over 10 to the 6th power. Well, we know that 2/11 is less than 1. And by the basic inequality property, we know that 2/11 times 1 over 10 to the 6th power is going to be less than 1 times 1 over 10 to the 6th power. So that gives us 2/11 times 1 over 10 to the 6th power is less than 1 over 10 to the 6th power, because again, multiplying that by 1 just gives us the same value. And that means that the value of 2/11 times 1 over 10 to the 6th power is less than 0.00001. And now we have confirmed that 3.181818 is a good estimation of the infinite decimal that is equal to 35/11. All right, let's do example 4. Write the decimal expansion of the fraction 6/7. So we're going to write the decimal expansion of 6/7. Will it be finite or infinite? And how do you know? Well, we know the fraction will not be a finite decimal because the denominator is not a product of 2's and or 5's. So we want to make sure we get enough decimal digits in order to get a good idea of what the infinite decimal is. What power of 10 should we use? Well, since we know it's an infinite decimal, 10 to the 6th power should be sufficient to make a good estimate of the value of 35/11. But again, any power of 10 greater than 6 will work too. However, the work we're going to show uses 10 to the 6th power. Again, if you want to pick 10 to the 8th power, you can do that also. So, using 10 to the 6th power, we have 6/7 is equal to 6 times 10 to the 6th power over 7 times 1 over 10 to the 6th power. And what do we do next? Well, 6 times 10 to the 6th power is 6 million. And then we need to do division with the remainder for 6 million divided by 7. So determine which numbers make the following statement true. 6 million is equal to some number times 7 plus some number. Well, that would be 857,142, and 6 would give us 6 million equals 857,142 times 7 plus 6. So now we know that 6/7 is equal to 857,142 times 7 plus 6 over 7 times 1 over 10 to the 6th power. So finish the work to write the decimal expansion of 6/7. So again, following the same process, I'm not going to read this through, but you can just step through it. We get 857,142 plus 6/7 times 1 over 10 to the 6th power. Then by using distributive property, we get our two products. And by simplifying 857,142 over 10 to the 6th power, we get a decimal 0.857142 plus, and then the other product is 6/7 times 1 over 10 to the 6th power. Again, we can verify how good our estimate is using the basic inequality property. We know that 6/7 is less than 1, even though it is really close to 1. But when we multiply 6/7 times 1 over 10 to the 6th power, it is still going to be less than 1 times 1 over 10 to the 6th power. And 6/7 times 1 over 10 to the 6th power is less than 1 over 10 to the 6th power. So therefore, it is going to be less than 0.0001. And that's stating that 6/7 is equal to 0.857142 is a good estimate. All right, complete exercises 1 through 3. You may use a calculator to check your work. Continue the video to check your answers. All right, you should be done with exercises 1 through 3. Go ahead and pause the video, check your answers, and then continue on. Make sure if you have any questions, you write them in the margin so you can bring them to class. All right, let's wrap this up. We know how to write the decimal expansion for any fraction. Using what we know about equivalent fractions, we can multiply a fraction by a power of 10 large enough to give us enough decimal digits to estimate the decimal expansion of a fraction. We know that the amount we do not include in the decimal expansion is a very small amount that will not change the value of the number in any meaningful way. All right, we'll see you in class.